mediums that you are going to submit or you want to send your information. Okay, so the example here is your telegraphy. Okay, telephony, facsimile, radio satellite, Wi-Fi, DRG, 4G, 5G, and so on lah, cellular system. So dalam case ni, as you can see that, so we are going to send the information. So the most important thing here, you want to send the information. So it means that at the transmitter, we have a transducer where you are going to send your signal using the transducer. The transducer means if you want to change, okay, you want to change your input signal, for example. Let's say it like this. So let's say this is your input signals, okay, and then you need to change this information. So this is your information lah. Alright, so your information, and then the signal dekat sini at the input transfer ni, basically input transducer is, we can consider that as a transmitter part. The transmitter consists of transducer, modulation, amplifier, and so on. So that one is all can be considered as a transmitter. So this is your transmitter. I put it TX here, and you have the output here is RX, receiver. So this is the medium lah, what we can say, medium of transmissions. So or the channels, what you can say, this is a channel of it. So your channel could be, okay, could be what? Could be your wireless or wired. If you talk about the wired, so you are going to have a wire to...
Doktor, ada budak nak masuk, doktor.
Siapa suruh lewat kata kat dia? Saya kalau lepas saya punya kelas, saya tak nak bagi masuk dah.
Okay, sorry doktor.
Mana? Sabarlah, saya kasih chance untuk baru. Siapa dia? Sebab every time that saya nak kena...
Nama dia Aiman Hafi. Dia apa, line dia lembab tadi.
Dan Abdul Rahman.
Okey, siapa lagi nak masuk? Amira, Aiman, Irma, Saya kalau dah start kelas, saya tak nak ganggu nak email. Sebab nanti kalau saya invite, senang lah. Sebab saya belum buat lagi, saya belum dapat email daripada kamu semua. So nanti saya akan cuba ni lah, invite through the email, so that kamu akan dapat dia punya ni through email. Okay, is there any more? Tak ada kan?
I think Mus ingat start 2 petang. Sam ingat start kedua.
Saya nak cover balik hari tu. Itu je.
Dah lupa kot.
Okay. Right. Tak apalah, nanti apa-apa dia orang inform je. Okay, so this is your transmitter, receiver as well as your channel lah. So this is a very basic communication lah. Ni kalau kita go into detail a bit, okay, what we can see that input transducer. So that means the input transducer, we can say that is inside the transmitter lah. And then transmission mediums and the receiver. So they just input transducer to, like, I mean, if you want to convert, for example, your voice signal to your electrical signal, so you need to put the transducer. Like microphone. Microphone is a transducer, what we can say. And then kalau output transducer means like a speaker. Speaker is your output transducer. Okay, so in terms of this, you can see that we have in terms of the whole communication system, the basic. So you have a transmitter, you have medium, you have a receiver. Okay, so this is sometimes transmission medium we call the channel. Okay, channel. Okay, so this is the definitions given. Like say FT is stand for the input signal. Okay, the input signal could be your audio, your voice, video, image, data, and so on. MTX ni actually is a modulating signal. The signals that you convert, you have a conversion from the voice signal that you have now, you change to the what we call the electrical signal. So that's why you have an input signal that has been converted to the electrical signals here. And then throughout the transmissions as well, you can see that we have a modulated signal. So output from the transmitter is actually a modulated signal. So we will learn later on about this modulated signal, where it depends on the what we call the input signal. Your input signal, you can see that you could be your analog or digital here. Boleh nampak tulisan saya? Kalau kata tulisan sometime. Memang saya punya tulisan macam ni lah. Nampak? Boleh agak tulisan dia?
Boleh baca.
Boleh tak ada masalah. Okay, so you have in terms of input signal here.
Tak
What?
faham doktor.
Ah?
Tak faham doktor.
Tak apa
Apa
nampak?
tu? Tak boleh baca doktor.
Tak boleh baca. Macam mana ni
Input
tak boleh baca?
signal, analog transmitter.
Input signal. Okay, could be your analog or digital kan? Tu boleh baca?
Yang ni boleh doktor.
Okay. So, jadi usually what we did from your video, from your audio that you have, okay, let's say for your from your voice, you have one device you call a transducer where you are going to convert your voice signal now to the electrical signal. Okay, your electrical signal actually for voice, as you know that this is what we call the analog signal for the voice. If you still remember, if you know. And then if you want to have the digital, what you need to do, you need to have the digital to analog converter or analog to digital converter. That means you convert from your analog signal to a digital signal. Okay, so that's why you can see that we have, in terms of modulating, we have analog modulation that we are going to see later, and also we have a digital modulation. So it depends on your information, basically, whether your information is digital or your information is analog. Okay, and then of course you have a transmission, as I mentioned to you before. You have a channel. So your channel could be what? Wired or wireless. Okay, so if you have wired, so it means that you will be connected directly from your transmitter to your receiver using wire. Okay, for example, your wire is your coaxial cable or fiber optics or waveguide. Okay, so but if you have a wireless means you are going to transmit your signal through wireless. So what does it mean? You need to have the antenna. Of course, this is your transmitter. So this is your receiver. Okay. So what you have, you are transmitting. So you have the signals that is being propagated throughout your free space. Okay, so this is what we call the wireless. So now you can see that we have a lot of application of the wireless, such as 3G, 4G, 5G, 6G, 7G, 6G, 7G, tak ada lagi lah, up to 5G now. And then we have the IoT, we have the satellite, we have a microwave, we have a radio, everything is wireless. Why do people prefer wireless? Because you can move around. Okay, kalau if you want to have like a wired, if you want to move from one place to another, so it is difficult lah. Definitely, it will be very, very difficult. It will be tangled around you because of the wire. Of course, throughout the medium here, you have a channel. Okay, transmission media, you have channel. Of course, from the channel, you have noise. Noise happen throughout this channel. So the noise, later on, we will explain. I will explain to you about the noise. Noise could be your internal noise, or it could be your external noise. Internal noise, it comes from the noise that happen in the devices itself. Okay, devices itself. Okay, for example, the resistor has a noise as well. The amplifier, the diodes, capacitor and so on. Though they consist of noise, because this one is, the noise is already there because of, in terms of the manufacturing, they cannot avoid it. Okay, and then we have another external noise, like the noise that the people do and so on. So you will learn about the noise later on in the special topic. And then of course you have the receiver. You see, your receiver here is what? You are going to receive back your signal. In this case, if you have the input is your voice signal, so you want to receive the voice signal, of course you need to, because of this is high frequency. This is all high frequency. This is high frequency. Okay, this one also high frequency. It means that this high frequency consists of course, frequency with plus your information. So your information is here actually. Okay, so in order for you to get back this information, okay, so what you need to do, you need to demodulate your signal. That happen here. Okay, so once you demodulate the signal, so you get back your information. Maybe your information is like this, right? And then of course you have a speaker, the transducer will change this electrical signal to the voice signal that you already transmitted before. So that is the output. Okay? Clear? Senyap ya semua.
Yes, clear.
Tak ada jawapan? Ha?
Yeah, clear up there.
Apa?
Clear as day.
So orang pelan saya nak kena increase the volume ke? Tak dengar.
Clear.
But you can
Tak dengar. Sekejap.
But you can listen my suara kan? My
Yeah,
voice,
I can hear you.
Yes.
Right.
Okay, yang lain macam mana? Okay ke? Dengar tak?
Dengar.
Okay. Wow, kalau semua jawab memanglah dia jadi kelabu pula. Okay. Alright, so this is the things that I already explained to you just now. Okay, so you have an input transducer, you have a transmitter, you have a transmission medium, receiver, as well as the output transducer. Okay, in terms of the signal, as you can see, you learned about the signal and system before. Okay, of course, in real, we have two, analog and digital. Okay, analog signal actually is a continuous, not really continuous, but what we can say that in terms of that is a continuous. So you have in terms of the analog signal. But if you talk about the voice signal, usually is a non-continuous, but it likes macam what we call that, we have to have like a Fourier transform to see what is the frequency inside there. Okay, the audio amplifier produces output voltage which can be any value within the range of power, more sensitive to noise, as noise is harder to be distinguished from desired signal. Okay, so because of why? Because kalau analog signal, you can see that sometimes, you know, if you have like this noise is somewhere, sometimes it's noise. So very, very okay to it. But like in this case, we know lah this is following the envelope. So, but if you are difficult to see this, maybe a bit more difficult to recover the signal from this analog, because the analog signal, basically the noise can be, you know, inside the amplitude here. Okay, so for digital, of course, usually what we can define is a discrete signal. So you need to have 1 or 0 only. Okay, so if a signal can be digital analog signal through analog to digital. So it means that you can have like digital signal here. Okay, from the analog, you need to have the digital to analog converter. Analog to digital converter. So you need to have this converter in order for you to convert from the analog to digital. If you want to change to analog signal, so you need to have a digital to analog converter, DAC and ADC. So these are two things that you should know. Okay, so we mean that we can have digital signal throughout the analog, or we can have directly digital signal, like from a computer. Computer is producing bits, binary 0, 1, so it's the digital signal. But nowadays, most of the system, as you can see, that they are using the digital system, digital transmission. Okay, so that's why they did a lot on the digital modulation. Okay, so we learn it later. And then in terms of signal classification, we have a continuous time and discrete time. Continuous signal can be described by function of continuous time. Example this. Okay, I think you are more expert than me because of you have learned this in the signal system before. Analog signal whose amplitude can take on any value in continuous range. Digital signal with finite values of your amplitude. Okay, periodic. Okay, as you can see that you have xt plus t naught. The smallest value of t naught is a period of xt no repetition. So as you can see that periodic and non-periodic signals. Kalau periodic signal is like a square wave or a sine wave or whatever. So it has a periodic time with a t naught. But for non-periodic, so no repetition, like your voice signal. Your voice signal is actually the non-periodic signal. Okay, so this is example of the signals as you can see here. Tak bergerak ah. Saya tak gerak ah. Tak bergerak kan? Lambat. Okay. Alright, so analog continuous time. Okay, so you can see that the signal, this is continuous time. So this is analog, digital continuous with time. You need to have a 1, 1, 1, 0, 1, 0. So this one is analog discrete time and digital discrete time. So we learn more this one if you study on the signal processing, because the signal need to process. Like this one, analog discrete time also, you are going to look in terms of the signal processing. Okay, a periodic signal, unit pulse, this is just an example, non-periodic, and this is the periodic. So you can see that, you see that you have just one like this. Okay, so this is in terms of pulse signal. So sometimes you have voice signal like this. Okay, for example. Okay, so this is a periodic signal, and this is a periodic. So example of periodic signal is a sinusoidal signal where xt here is this. So you need to have like T naught here. Okay, so dia kelabu lah semua. This is more on mathematicals lah. From here you can see that you have in terms of a periodic signal. Usually for the periodic signal you can see we have in terms of time here. Okay, this one later on I will explain to you on this. And then you have the harmonic signal. Okay, of course, if you look in terms of this signal, basically this signal is coming from the square wave. Actually, the square wave, kalau if you do on the Fourier series, you can see that it is a combinations of harmonics and fundamental. Okay, so that's why if you want to find this kind of signal, what is the spectrum frequency inside here? So you need to do a Fourier series in order for you to obtain the frequency spectrum from this. So that's why last time you learn about this signal, okay? This signal, you learn about this signal and so on. So but you want to see what is the content of the frequency here. Okay, like this one, you see that we have the harmonics, we have like this. Okay, and then you have another one, small one. You have another one. So we have like a fundamental. So this is a fundamental. And then this one is the first harmonic, maybe second harmonic, and so on. So the combination of all this, you can see that you are getting the sinusoid, the square wave signal. Okay, so this example, you can see that in terms of time domain. All right, time domain. So the amplitude here, amplitude, and this is a time. Okay, because if you want to see this the signal in the time domain, you can use the oscilloscope. But if you want to see the spectrum, you have to use a spectrum analyzer. So these are two different devices that you are going to use for your signal to be measured. Okay, Afiq, nak suara sikit? Afiq Nakiuddin. Mana? Tak dengar apa suara? Nanti saya akan panggil nama aja.
Ya Doktor, ya Doktor. Okay.
Ada pun. Ingatkan dah hilang dah pergi
Ada.
pergi makan ke apa. Alright. Okay, clear. Itu just now is more towards the ni je lah. Okay, basic idea. Dia tak bergerak juga kadang-kadang. Saya dah masuk transmission dah ni. Saya tak bergerak. Tak bergerak kan?
Tak.
Okay. Alright. Okay, saya terpaksa kena ada dua komputer lah. Nak tahu gerak ke tak gerak ke. Tidak nanti kan saya ada cakap seorang ya. Okay, so in terms of transmission medium or a guided, as you can see that we have of course we have a cable. So cable can be defined as you can have a different cable as well. Okay, so any conductor with a transmission and with the ground plane, so we have in terms of the cable lah. Okay, we have a different type of cable as well. For example, you have twisted pair, coaxial cable, fiber optics, waveguide, microstrip line, and so on. So this is what we call the transmission line or transmission medium. Okay, so of course, fiber optic will be using for the light communication. They are using the fiber optic. Microwave, of course, they are using for the microwave frequency. Microstrip line can be used for microwaves as well as the low frequency as well. Maybe coaxial cables, if you want to see, you go back or you see from your home, from your TV. If you have the digital TV or you have a TV, okay, you can see that there is antenna connected to your decoder or TV. So that is what you call the transmission line. It's a coaxial cable. Okay, twisted pair, I think this is the old one, and also it's still used in telecommunication systems. Okay, shielded and unshielded. Shielded usually is for high frequency, unshielded is for the low frequency. Right, okay. So if you look in terms of your transmission medium, tak bergerak pula balik. Okay, if you look into all your transmission medium, of course, transmission medium, if you have in terms of your unguided ni maksud dia you are talking about the wireless lah. So tergerak. Dia pergi kat electromagnetic spectrum, dia tak gerak pula dah. Mana pasal pula dah. Saya punya ni dah bergerak, yang kat sini tak bergerak. Okay, if you look into all the transmission medium, okay, for the guided, just now what we can say that can be considered as a guided lah. For unguided, that means that is what we call the wireless lah. Wireless means you need to have a frequency spectrums that can be used for the transmission. So this is very, very important, because nowadays as well we can see that we have a lot of different applications, especially for the wireless. Macam-macam. Can you give me the example of the application of the wireless here? Okay, Megat Azri Irfan. Okay, can you give me the example of the application for the wireless that you know? Megat?
Ya saya. Wireless
wireless application.
Bluetooth speaker.
Bluetooth speaker, okay, correct. What frequency is it?
Tak tahu.
Tahu je guna. Bluetooth tu sentiasa duduk dekat telinga. Okay, alright, that's correct. Okay. Iskandar Zulkarnain. Oh, saya ada nama sini semua ni.
Ya, doktor.
Tak tahu? Macam mana nak ambil communication?
Radio.
Okay,
Radio.
one of this is the radio. Lagi? TV. Lagi? Apa lagi? Your handphone. Every day that you use your handphone. Yeah, it's a wireless as well. Okay. Handphone dia ada apa? What we have a 3G, 4G, 5G. That is all the wireless. That what's called a cellular. Banyak tu ya. Satellite. Lagi? Microwave link. Okay, so that is about the unguided lah, wireless. Free space. So that means that the medium of transmission is a free space. So that means you transmit your signal through your free space, and then a receiver so receive, and then they demodulate whatever information that you are transmitting. Okay, if you look in terms of the electromagnetic spectrum here, okay, the electromagnetic spectrum here, as you can see that this is the radio frequency of the spectrum. Okay, so as you can see that from here, the frequency start from 30 hertz, you see, until 3,000, apa dia panggil hertz. I can't remember, but maybe you can refer through the internet. Is there anybody knows? E tu.
Exahertz.
Cuba, can you look back through the internet if you can have it? So find what is the EH and PH. Saya boleh lupa lah. EH and PH. There is a shop.
Exahertz. 3000
Exahertz. And another one? Petahertz. Sorry, petahertz. Saya pun lupa. Okay. Okay, so P is the capital letter for P is a petahertz and E for exahertz. Okay, so you can see that from 30 hertz, H to small hertz. Hertz ni pun actually is the name of the people who invent this. 300 hertz, 3 kilohertz, 30 kilohertz, 300 kilohertz, 3 megahertz. Okay, that is 3 megahertz, 30 megahertz, 300 megahertz, 3 gigahertz, 30 gigahertz, 300 gigahertz. 3 T from stand for what? Does anybody know?
Tera.
Okay, terahertz. Okay, 30 terahertz, yeah, is correct. 300 terahertz, 3 petahertz, 3 exahertz. Depan ni tak tahu lah. Dia tak bagi. Okay, ada lagi. So actually this one is a short form only, like kilohertz lah. We know that is a 10 to the power of 3, mega 10 to the power of 6, giga 10 to the power of 9, tera is 10 to the power of 12, peta is 10 to the power of 15, 8 stand for 10 to the power of 18. Okay, because the other way, we start with the milli, yeah. Milli is 10 to the power minus 3, and then lepas milli, sebelum milli, micro. Micro is 10 to the power of 9, and then 10 to the power of micro is 10 to the power of 6 minus 6, and then 10 to the power of 9 is a nano. And then 10 to the power of minus 12 is a pico. 10 to the power of minus 15 tak pernah guna. Tak pernah guna. Femta. No, bukan femta. Pico, femto. Okay, and so on lah, ada lagi. Okay, so jadi if you can see in terms of the electromagnetic spectrum, the radio frequency, they have a certain range as well. For example, if you have from 3 to 3 kilohertz, 30 hertz to 30 kilohertz, they call the VLF. Very low frequency. From 30 to 300 kilohertz, they call LF. Low frequency. From 300 kilohertz to 3 megahertz, you have MF. Medium frequency. And then from 3 megahertz to 300 megahertz, 3 megahertz to 30 megahertz, high frequency, HF. And then from 30 megahertz to 100 megahertz is a VHF, very high frequency. And then from 300 to 3 gigahertz, we call the UHF frequency. And then from 3 gigahertz to 30 gigahertz, they have SHF, super high frequency. 30 gigahertz to 300 gigahertz, they call the extra high frequency. Okay? And then after that, it goes to sub-millimeter. And then they go to all these things lah. All these things ni dia jadi ultraviolet, X-ray, gamma ray. So this is the range of frequency that is not suitable to be received lah. It can cause cancer, as I mentioned to you before, because this frequency actually is ionized frequency. The rest is okay. This is a non-ionized. Okay, right? So as you can see that in terms of radio wave, the arrow here say that it goes up to 3 gigahertz. That means above than 3 gigahertz is microwave. But now they are defining a bit more difference now because of, okay, why? Because of maybe for this radio wave usually is the frequency that usually we use for communications. Okay, but now we are talking about we are going to use it the communication above than 3, let's say for 6 gigahertz and so on. Maybe they will be changed later on in terms of the frequency for the radio waves. Okay, for the microwave they define from 3 to 300 gigahertz, and then inside of the microwave also we have the millimeter wave. Okay, millimeter wave, it come from this all frequency from the IEEE or military lah. In this case, we have UHF, L band, S band, C band, X band, KU, KKA, and millimeter wave. Okay, so you define millimeter wave is above than 40, but in our case, usually we can consider 26, 28 also can be considered as a millimeter wave. Okay, and then after that they have in terms of the sub-millimeter wave. So this is they using for the photonics lah. So or sometimes we can say that we are using the terahertz. Terahertz mean we are using the photonics range for the optical lah. But there is a system on the terahertz application. Terahertz. Terahertz means they are using this particular frequency 300 to 3 terahertz. So this was as a communication like a wireless as well. By this moment, for the opticals, they use the optical fiber as a guided with the guided transmission line to guide the light inside your optical communication or optical fiber. Sorry. Okay, right. Okay, how close communication efficiency? We can measure the level of efficiency of communication system through several ways. How close the signal to transmit input signal? Okay, we need a high quality of transmission. Analog, of course, we usually measure in terms of the signal to noise ratio. What is it mean by signal to noise ratio? As you can see that this is the frequency here. So this is this is the amplitude. So this is the frequency for the around this frequency. So kita ada what you call this is noise level lah. And then of course we have a signal here above than this. So above than this, we call is called the signal to noise ratio here. Alright, so the signal here over noise here. So it means that the higher your signal to noise ratio, the better your system lah, because of the signal is not in the noise level. But if this is your noise and your level of your signal is here, I'm afraid that if the noise a little bit more bigger, so you can see that your signal is in the noise region. So what happened? You cannot get the information. So this is very important to have in terms of your signal to noise ratio, that if you design something, you need to have the correct signal to noise ratio so that you will receive the information or the signal that you are transmitting. Of course, in the digital, we consider as in terms of BER. BER stands for bit error rate. How many bits, okay, that has an error in one particular transmission. For example, if you have 1,000 bits, and then you have one error. So you have, that means BER here is equal to 1 over 1,000. But it's good lah. But if your bit error rate is very close to 1 over 100, so example, you see, in 100 bits, you need to have one error. Okay, or if you have 1 over 10 bits, so you can see that in 10 bits, you have one error. So it's not good your system, because you are getting to have a lot of errors later on. So this is how they measure the digital signal, the BER rate for the lot they use in terms of the signal to noise ratio. Okay, and then how much power needed to transmit multi-signal? Low power, lifespan of a battery is longer. High power, lifespan of battery is shorter. Okay, as you can see that your handphone, okay, if you are using too long, for example, you can see that your battery akan jadi and then at the end no battery, because you are using the power. Okay, especially bila when you are having at longer distance, because they need to have more power to transmit so that you can still communicate. Okay, how much bandwidth is needed to transmit the voltage signal? Low bandwidth communication means user can share the communication medium. So it depends on the applications again. So usually the bandwidth is depend on the application, and then low bandwidth application means more user can share the communication. So it means that if you can have a smaller bandwidth, so more user can use. For example, let's say you have 1 megahertz. Okay, 1 megahertz. Let's say for application of the radio, let's say you need to have 10 kilohertz. Okay, one user use 10 kilohertz. If you have 1 megahertz bandwidth, so what is the number of user? 1000, let's say, bagi dengan 10. So you have 100 users simultaneously in 1 megahertz. Is it correct? I did. Okay, what happened? If you can respond to me, I don't mind giving you the information. If you are confused or don't understand, just ask me and then I can repeat it again. Okay, for example, if you have 10 megahertz, it means that you have 10,000. Okay, you are using the same bandwidth bagi dengan 10, so you can see you have 1,000 user now. So this is how bandwidth will improve in terms of the users. How much signal or signal size needs to transmit also depend on the bandwidth. This just depend on bit rate. Of course, we will learn later on in terms of bit rate for the digital signal. Okay, so that's why kebanyakan kita boleh tengok sekarang what you can see that. Okay, your data rate, for example, your data rate is, let's say, 2 megabit. So faster lah. Okay, you need to have, but 2 megabit per second means you need to have a 2 megahertz as well. Bandwidth that need to be occupied here. Okay, right. So obstacle to communication system. Okay, of course, you need to have a technology problems, hardware, economy, law, and regulations. And then physical problem is your bandwidth, your signal power, as well as noise. Noise will affect your communication systems. Okay, the higher the noise that you have, maybe sometimes you cannot receive your signal. Okay. Okay, all right. Important parameters here. So we will learn later on more details. Bit rate actually is 1 over TB. We can say the FB here. Okay, so usually we consider as parameter of moments for the digital systems. The number of bit per second inverse of bit duration, 10 gigabit per second. Bit rate is actually 0.1 nanosecond bit duration. So if you want to consider as in terms of time here. Industry keeps demanding for higher bit rate due to user demands. Okay, the bandwidth, a range of frequencies, characteristics of information, channel, mediums, or devices. Okay, for example, voice 4 to 4 kilohertz, optical channel 100. B is related to FB. FB is your bit rate here. Signal bandwidth depend on analog or digital modulation formats. Example, bandwidth of EM signal is FM or to FM. Now return to 0, you can see that this is for digital. You see you have FB over 2 or return to 0. So it depends on the coding. So this is what you call the coding that you are going to learn, coding system. You are going to learn in the digital later on. Bandwidth is a valuable resource in communication system. Okay, of course you have in terms of the channel capacity. Channel capacity is much depend on your information. So we can calculate using the Shannon limit where the channel capacity is actually to B log 2 1 plus n. B log 2 maksudnya 2 kat sini kat bawah, bukan kat atas. So you need to put the log 2 here. 1 plus your S over N. S over N is your signal to noise. So B is the channel bandwidth. and as well as the signal to noise ratio. So you can calculate what is the channel capacity using the channel limit here. For given SNR, channel with higher bandwidth has higher capacity, see? So if you have a signal to noise ratio, channel with higher bandwidth has higher capacity. Of course, so if you increase the bandwidth here, of course the channel capacity also will be increased even though you stop signal to ratio, I mean you fix it. Medium wireless optical links that has larger capacity can support more users. Okay, another important thing in communications, I think for me is not thing again. For me is very very important. Very very important the communication in terms of the DB units. Okay, so the DB units actually is just a ratio basically. Okay, it's just a ratio. Okay, so another. For example, if you have a P1, okay, so for example, if you have like this, okay, you have input here P1 and P2 here, right? So you have a certain value, for example, 100, and then this one become 1, contoh. Okay, power here is 1. So basically what you can see, you can find the dB value of the input or output over input. So the P output over P input is actually is equal to what? P output is 1 over 100. So in terms of the absolute value, you have 0.01. But if you are going to take in terms of the dB, so you have to put 10 log, okay, P2 over P1 here. So you have 10 log. P2 is 0.01. So what is this value that you get? What is this value? Can anybody give me the answer?
Negative 20.
Negative 20. Okay, because you can have like this one minus 10 to minus 2 isn't it? Is it correct? Minus 2 this one. 1, 2, okay, minus 2. 10 to power minus 2 So jadi you bring the minus 2, 20. So negative 20 dB. Okay, and then for example, if you have another one, okay, the device, okay, you don't know what is the device. You have the input power one is 10 watt, and then the output here become 100. Okay, what is it? So the ratio between the power output P2 over P1 is 10 log in dB, 100 over 10. So what is this value in dB? So this is all in dB. Okay, can anybody give me the answer? What is this value?
10.
Okay, 10. Right? You see, you have a 10 dB here. You have 20 dB here. But this is negative. This is positive. What does it mean here? What does it mean?
Increase becomes
Marisa
positive.
Mazlan, I want to see. Okay, I want to see whether you are here or not. Marisa Mazlan. Nanti kalau siapa saya panggil tak ada nama, saya tolak kata tak datang. Okay, that's the way. Sebab setengah tu pergi toilet lah, pergi mana. Ada. Dia keluar hijau-hijau tu, dia okay, Marisa Mazlan. What do you mean by this? Minus 20, plus 10. What does it mean? Senyap je. Speaker hilang. Speaker hilang ke?
Hello.
Dengar tak? Okay. What does it mean, Marisa? Buat sikit wajah. Saya ni nampak kamu RM je.
Kamera saya problem lah tu.
Alasan. Make sure next time saya nak video mesti kena ada bila kamu cakap. Everybody of you. Okay, saya tak nak saya cakap macam saya cakap seorang. Okay, just when I'm asking you, so we make sure that you on the video and you answer my question. Okay, what does it mean by minus 20 and plus 10, that one?
I think the power output is higher than means the power output is produced larger than the input.
Okay, as you can see that you have 10 is higher, minus 20 is lower lah. Maksud dia like that, is it?
Yes. Is it correct?
Okay, so what does it mean? Is it
Sorry?
there is a what? Amplification or in attenuations?
Attenuation.
Where is it? Which one is attenuations?
The 10 dB, I think.
10 dB is attenuation. How come? You inject the and then you come up with 100 watts. So of course that one will be the amplifier.
Sorry.
So this one could be your attenuations. So this one is what we call, sometimes we call the losses. So that's why sometimes if we didn't put this, let's say for example, losses equal to 20 dB. What does it mean? The value must be negative. Remember, a lot of students confused is that if you didn't change to negative 20 dB, so it means that your calculation later on will be wrong. Okay? Will be wrong. Okay, so that's why in terms of the dB unit, you have to be very careful. All right, so if you want to change in terms of the voltage, as usual, the output over input as well. V2 we assume as the output, V1 is the input. So the only thing that you need to put 20, because why? As you know that P here is equal to IV, okay, I2, for example, over, V square over R. You want V square over R as well. Okay, V2, V1. You can see? So, okay, so from here you see, the conteng habis. Conteng habis. Okay, so you can see that you have V square over R. This one over V square over R. Of course, this one is 2, V1. So R and R cancel. So you bring 2 here. So you have V2 over V1 square. So you bring 2, 10 log. So you have 20 log V2 over V1. Okay? Alright? Clear? Tak nak jawab, saya tak nak continue. Okay. Because nanti kalau quiz ni banyak saya tanya soalan macam ni. Okay, so this is example. You can see that absolute. Okay, I give you the example. Alamak, tak bergerak lah. Siapa dia tak bergerak? Purpose of using dB to show the ratio, loss, gain, and sinusoidal communication. Power can vary milliwatt from picowatt at receiver. Easier working in dB than absolute linear form. Okay, because kalau kamu tengok, if you can see from the dB value, actually you can just add easily. You can add easily. Okay, you can just add. Well, if loss means you have minus, gain you need to plus and so on. At the end, you can just simply, for example, let's say if you have a receiver, you receive signal, you have the amplifier, you have some mixer here. Okay, you have another amplifier. Okay, for example, and then you have your detector, and then you go for your speaker, for example. So basically, if you have like, so this one is 20 dB, example, receive, maybe you receive in terms of minus 10 dB M. Okay, I will show to you later on the dBm. And then losses, we have a minus 6, we amplify another 20, we have another detector minus 5, for example. And what is the output here? Okay, basically the output here actually is equal to minus 10 plus 20 minus 6 plus 20 minus 5. So total. So you can see it's very easy to do the calculation from the receiving part up to the output part. Okay, right. There is another things that is very important as well from our lecture is in terms of dBm, dBw, dBv and so on. Aduh, tak gerak pula dah. Okay, you see that we have P1 here, 1 milliwatt, P1 here, 1 watt, V1 here, 1 watt. So basically you can easily change in terms of this, okay, 1 milliwatt actually is equal to how many dBm. dBm means ratio is 1 milliwatt. So what you can see, you have 10 log y is the power over 1 milliwatt. So this is what we call dBm. dBm, dV mu in microwatt. You refer to 1 microwatt, 10 log. Okay, power 1 microwatt. And then you have milliwatt, microwatt, watt, V. V depend on the voltage. Watt is based on the power measurement in unit watt. Kalau dBW in watt, so is equal to 10 log your power over 1 watt. Okay? Right. Now I want to ask you. Okay, if you have power of 1 milliwatt, what is the power in dBm? Okay, somebody tolong answer. Mana lah ni, saya pun tak tahu lah. Nak padam ni. Senyap memang sunyi sepi
Sekejap.
If your power is 1 milliwatt
1 dBm, Doktor.
1 milliwatt 1 dBm siapa ajar tu? Siapa yang bagi tu answer tu? 1 milliwatt 1 dBm siapa? Who is it? Max. Who is it? Nick.
Is it 0, Doktor?
Nick Umar.
No,
Who give the
wasn't
answer?
me.
Oh, tak ada.
Takut nak jawab.
Asmilas.
Takut nak jawab.
Okay, cuba tunjuk muka sikit. Farah Akilah. Oh, nampak macam artis ni. Okay. What is the answer? Tunjuk muka sikit. Ataupun kalau duduk kat rumah, tak boleh lah. Terbuka tudung semua nanti. Okay, so but make sure that you kena on video juga bila saya panggil nama. Tak kisahlah kamu ada kat rumah ke, kat mana ke. Farah Akilah. Saya tak nak kamu tidur semua ni. Hilang langsung. Tak bergerak apa?
Saya.
1 milliwatt is what? Mana rupa? Cuba pasang video. Malu? Malu apa? Saya pun nak malu macam mana?
Saya pasang.
Tak apa, next time kalau tak pakai tudung tu, prepare lah pakai tudung bila kelas saya nanti kan. Terbuka pula nanti. What do you mean by 1 milliwatt here? Berapa dBm? Tak sure.
So is it 0 dBm?
Yes. Who is it giving me the answer?
Tekpal.
Tefka. Wow. Where are you from? Are you international?
No, I'm from Malaysian. Dari Selangor. Dari Selangor, Kacang.
Okay, that's correct. 0 dBm. So 1 milliwatt, you refer to 1 milliwatt as well. Okay. So log 10 1 is equal to 0 kan? So is a 0. So the answer is a 0 dBm. Okay. Because you need to know your dBm like this is equal to 10 log whatever power that you have over 1 milliwatt. If your power is 1 milliwatt, it means that you have 10 log so 1 over 1. Log 1 is equal to 0, so you have 0. Okay. The same thing if you have power is equal to 5 watt. In dBm is equal to what? 10 log 5 over 1 milliwatt. What is the answer for this one? Anybody can give me the answer?
There is 6.99.
36.99.
30? What is the answer?
36.99.
Okay. So 37 lah. dB M. Okay? Right? So same thing for others. Let's say for example you want to change to dB mu. dB mu is actually equal to 10 log. If your P is 1 milliwatt, okay, what is your dB mu here? If your P is 1 milliwatt, what is the P here? What is in dB mu? Huh? 30. Correct. 30 dB mu. Okay, so you can practice it and then see how. Because actually 30 dB mu is equal to 0 dBm. Is equal to 1 milliwatt. The thing is the same. Okay, the thing is the same. Alright, okay. So if you look in terms of the transmission, as I mentioned to you before, okay, so your L, transmission, losses, attenuation is the major source of your transmission loss, occurs along the transmission medium, will attenuate power and cause power loss. So power loss, P out less than P in, power loss or power attenuation is given by P in over P out, or is equal to LG lah. The equal is missing here. Okay, I don't know why it's missing. Okay, so this is the attenuations. Attenuations is something that when you put in, and then the signal is less. Okay, so it means that attenuation. So sometimes we can say that is a losses happen in that particular transmission line. Okay, for example, you have cable terpiok. This is all the Malay words. Twisted pair cable. Attenuation is about 2 dB, 3 and 6. You can imagine this is 1 kilometer. If your cable, 100 kilometer cable, how many dB? So you have to multiply by 100. So this one is become 600 dB in 100 kilometer. Banyak tu. Lot of loss. 600 dB is a lot already. Okay, so that's why cable losses, it depends on the application frequency as well as the long. What you can do, you can use a shorter one so that you can have less losses. Okay, optics is okay. Microwave, waveguide, it did not really have in kilometer. We say that 5 dB in that particular application, for example. Okay, all right. So, example here, calculate if its value dBm is 0 dBm. I did so many times. How you want to do that? The value of power is equal to 0 dBm, and then tak boleh keluar. Okay lah. Zero dBm, and then how to get this one? dBm is 10 log power over 1 milliwatt, isn't it? And then it's equal to 0. Okay, so log power over 1 milli to 0. P over 1 milliwatt is actually 10 to the power of 0, so it's equal to 1. P is equal to 1 milliwatt. Okay, calculate signal power in dB if the value is 1 milliwatt. How you want to do this? Signal power in I think in dBm, because you cannot calculate power in dB, because for dB you need to have a ratio, right? So maybe dBm here, so it's the same thing. The answer will be the same. And then you can see that was suppressed by 20 dB. What is the carrier's new amplitude? What does it mean here? So you need to start with 20 log something. You have a suppressed new, for example, is equal to 20 dB. And then you do that voltage, and then you just multiply with the new one. You want to find what is the new one with the 20 dB less minus 20 dB, so you can get the value. Okay, because sometimes in the questions, okay, we give this and then this signal suppressed, that signal suppressed, so you need to know how to change it. Okay, all right, is there any questions? Okay, I think this one should be next week. Noise. Is there any question before we dismiss this class?
Yeah, can we solve the last example?
Yeah, doctor, I don't understand the last example.
Yeah, can you? Okay, can you solve and then show it to me now?
Yeah, after we do the sides, what else?
After
we put the values on the right side, on the left side, then what is next?
What is it? What is the answer supposed to be? Can you give me the answer and then I can say whether the answer is correct or not?
I'm just confused about the mathematical process of it. I mean, how can we solve the both sides when there is log there?
There is no problem in solving that. Okay, can you try to do that? How is it? So you have 20 here. Log whatever value that you have, V2 over V1, because this is in voltage, you see. You have to see that whether is it in watt or is it in voltage. Okay. So for example, let's say if you have like this one, so you need to find out what is the values that you suppress in this case. Okay, so you have 20 log whatever values that you have here. Okay, let's say for example you suppress is 100 over whatever value here, 20 dB, 20 dB, is it? So you can see that you suppress mean you need to have a lower value. So for example, maybe you can put in terms of the minus 20 here. Okay. So,
Doctor, what does it mean by suppressed?
Suppress means like this. If you have the amplitude, for example, I just give it to you. Let's say you have this amplitude, this carrier signal. That is the example. Okay, so of course, you have the amplitude here. Okay, there is a certain values, maybe 10 volts here. And then it suppress means you suppress the signal here, the amplitude. So maybe this one is become 5 volt. So in this case, what is the value of the suppressions that you have? Okay, So you can define it based on whatever values that you have, 20 log. For example, 5/10, you suppress it, you suppress by 5. So what is this value? I need to use the calculator. No.
Negative 6.0.
Yeah, it's about -6. So that means you are suppressing about -6 dB, or maybe you suppress 6 dB. Okay? Understand?
Okay, understand.
Alright, so you can solve the problems. What is the answer that you get? I just want to see what is the answer that you are getting.
10 volt.
Huh?
10.
Okay, correct. That is the answer. Is a 10 volt. Okay, very good. Okay, alright. Is there any questions? Okay. Then we have another 10 minutes to go. Just brief. Yes, okay.
No.
Huh?
I think there is no question.
No question. And then you want to sleep now.
No question tu further.
Huh?
No
Brother,
question.
the last example, right? VCT dia nak the new carry amplitude, so you have to minus lah 100 cos minus 10
Yeah.
becomes 90.
What
90
what
cos.
do you mean? Because you suppress, that mean the amplitude must be less, definitely. You cannot have more.
So the final
Because
answer
you
is
suppress by with a negative, with a 20 dB, it means that is equal to minus 20 dB. I think you just follow you can get the answer.
okay.
Okay, the step here. Because I show you to make you more understand. Alright, so like this, for example, I repeat again. Let's say you have this signal is about 10 volt, right? 10 volt, and then you suppress, and then the value is 5 volt. So the question is, what is the values that you suppress, okay, to get 5 volt? Okay, so you just take 5/10, 20, multiply by 20 because it's a log. So you get negative value. So it shows that negative value is you are suppressing roughly about 6 dB. Okay?
Okay.
Alright, boleh ke? Tak jawab pun?
Okay, doktor.
Boleh doktor.
Boleh, Alhamdulillah. Okay.
Alhamdulillah, syukur.
Apa?
Syukur. Alhamdulillah.
Syukur. Tu tak lagi boleh sambung tidur kan?
Saya nak pergi kedai doktor.
Oh iya ke? Nak pergi buat apa? Mana boleh
Repair
keluar?
motor.
Dia tak boleh keluar?
Saya Negeri Sembilan doktor.
Negeri Sembilan pun tak boleh. Tak boleh berjangkit.
Alhamdulillah.
Okay, so for the next weeks, make sure that you refer my notes as well. Okay, so that we can have a better understanding when I explain to you. Okay. Nampak tak saya bergerak-gerak ni okey lah? Tak nampak?
Slow. Lagging.
Slow Saya terpaksa kena buka dua komputer tu nak make sure that you all nampak. Pasal apa dia page next? Sebab dia tak nampak pula kat sini. Aduh. Oh, nampak tak ni? Dia punya ni? Slide
Yang kira-kira tadi tu lah.
Yelah. Nampak lah. Tapi saya tak nampak pula kat sini. Saya tak sure sebab apa.
Nampak.
Saya tak nampak. Alamak, silap. Tak nampak pula lah. Mana pergi hilang. Dia menghilangkan diri. Tapi kalau nampak okey lah.
Nampak doktor, nampak.
Nampak Sebab saya punya ni tak nampak. Saya pun pelik kat saya. Tadi saya nampak sebab saya nak make sure that every slide yang saya hantar, yang saya bagi tu, you all boleh nampak. Okay, anyway. So for the next week, kita tak ada quiz lagi lah ya, Kot lah. Hari ni saya nak bagi, tapi tak sempat nak, tak habis lagi saya nak buat Google
Tak
Form.
apa doktor, tak apa doktor. Take your time. Take your time doktor. It's okay.
No, tak okay bagi saya. Okay, so make sure that next week, I don't know, maybe I just come here, I give you a quiz on Wednesday tu morning, pukul 8, be prepare lah. Saya bagi about 10 minutes saja, so everybody should say. And then saya akan automatically, dia akan just marking untuk saya terus lah. So that the answer is ABC code, saya rasa. Okay. Right. So another thing, nobody want to order the books. I have the books already here. Huh?
Dah beli tu. Dah beli.
Kau beli kat mana?
Already have doctor.
Ha?
Dah beli.
Already have.
Dekat mana beli? Dekat
Dah beli doktor, kat Shopee je.
Nanti make sure that everybody bring the book.
Kat Shopee murah doktor.
Ha?
Dekat Shopee.
Oh, ada kat Shopee ke?
Ada?
Ada. Banyak
Macam
buku
mana dia boleh ada
doktor.
kat situ? Macam tak betul je.
Jual kat abang ada jual doktor.
Sebab dekat Shopee tu dia memang UTM punya ni lah. Dia UTM punya macam kedai.
Oh, okay.
Koperasi UTM.
Okay. Tak apalah kalau kamu beli kat Shopee, it's okay. Okay, alright so no question. So I need to get the what you call the QR code before you leave. Because your attendance as usual I put in the e-learning. Okay, saya nak tanya, I just want to ask you, who watched the video that I upload this, the 5G and Internet of Things to the e-learning? Nobody?
Yes sir.
Who watched that video? Nobody watched. Okay, most of the information selalunya I put in the ni e-learning sebab we want to make use the e-learning from UTM. Tak boleh masuk pula ke e-learning.
Mana sir attendance?
Dah ada hal. Okay, we stop here. So we continue next Wednesday. As usual, I try to be at 8 o'clock. Okay, if a bit late, maybe 8:30 we start our class. Okay, and then on Thursday as usual. Do you have a class after this? Huh?
No, doktor.
No class. Last time you all kata ada class. Okay, in that case maybe sometime